Good morning, boys and girls. Today we are talking about whole numbers and fractions. And before we get started, I wanted to show you this number line that I made. It is going to end up looking like this, but that's not how it started. I started with a plain sheet of paper, and then I got my ruler out, and I drew my straight lines, and I actually used my 6-inch ruler. You have a 6-inch ruler in your toolbox, and I marked off where 1, 2, 3, 4, 5, and 6 inches is found on the ruler. And I did that 1, 2, 3, 4, 5 times. And once I had finished that, I went back and I set up my number line. We'll be using this later in our lesson. So if you want to make a number line like this, you might want to stop the video now, go get your paper and get it set up. Or I did send this number line to your parents in my email. Perhaps maybe they could print it out if they have that ability, or you could just look at it on the screen. So we will be using this in just a little bit. But let's start out with our lesson for today. Lesson 13-7. Jamie's family ate 12 pieces of apple pie during the week. Each piece was 1/6 of a whole pie. How many whole pies did Jamie's family eat? What fraction of a pie was left over? Explain how you decided. So the first thing we're going to look at is, we could use reasoning. Think about the size of each piece and the size of the whole pie. So we know that each piece is 1/6 of a whole pie, and that they ate 12 pieces. So we could draw a fraction circle, as they have already done for us, and they've already divided it into 6 equal pieces, each pie. So if each one of these is 1/6, and Jamie's family ate 12 pieces, then it would be like shading in all the pieces up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I've shaded in my 12 pieces of pie that Jamie's family ate. But let me look back at what my question is asking. How many whole pies did Jamie's family eat? Well, let's take a look. 1 whole pie, 2 whole pies. So they ate 2 whole pies. But as always, we have to look carefully at our questions because I see that there's 2 questions here. The next one says, what fraction of a pie was left over? Are there any leftover pieces? No, there are 0 pieces left over. Now when we look back, we can see that our problem is going to continue, but with a little bit different set of numbers. Jamie cuts another pie into smaller pieces. Each piece of pie is 1/8 of the whole. Jamie gives away 8 pieces. Does Jamie have any pie left over? Explain how you know. So we're going to draw our circle, and this time I know that my whole pie is going to be divided into 8 pieces. So I'm going to take my circle, and I'll make it into 4, and then I know that 4 doubled is 8. So then I'm going to split each of these 4 sections apart. Now, this time it says Jamie gives away 8 pieces. Well, let's see. Shading in 8 pieces that she gave away. 1, 2, 3, 4, 5, 6, 7, and 8. If she gave away 8 pieces, how many pieces does she have left over? You're right, 0 pieces left over. And we would know this because if the pie is broken into 8 pieces and she gives away 8 pieces, obviously she will have none left over because the whole pie could be represented by the fraction 8 pieces out of 8 sections of pieces. Let's turn our page. So when I look at the back, we could also use a number line to represent our fractions and our wholes. And that's what we're looking at this time. At the top, it says, what are some equivalent fraction names for 1, 2, and 3? So we have our whole numbers 1, whole number 2, and whole number 3. And let's look at what our person is telling us. You can write a whole number as a fraction by writing the whole number as the numerator and 1 as the denominator. We've talked about how to make a fraction if we divide it into smaller pieces, but what if our pieces are not divided and each section is one whole piece? It says the number line shows 3 wholes, 1, 2, and 3. Each whole is divided into 1 equal part. So this whole, only 1 part. This whole, there's only 1 part. And the final whole, there's only 1 part. So 1 whole divided into 1 equal part can be written as 1 over 1. 2 wholes, each divided into 1 equal part, can be written as 2 over 1. So right here, 1 whole, that's 1 part that we're thinking about, and the denominator is divided into 1 whole, so 1 over 1. And if we go to the second one, we're still, each part, our denominator will stay the same. Each part is still divided into 1 part. And so how many parts am I thinking about? 1, 2. So 2 out of 1 parts, because 1 part, each time my denominator stays the same. It's not divided into anything but 1. And so, of course, that makes my 3, I have 1, 2, 3 wholes that I'm thinking about, and each whole is divided into 1 part. So this is how we could write 1 whole as 1 over 1, 2 wholes, 2 over 1, and 3 wholes would be 3 over 1. Now we can also find other equivalent fraction names for whole numbers, and if we look here, they've got our number line. The first thing I'd like to do is highlight their whole number because it kind of gets lost with the other fractions that we're looking at. So the whole number 1, whole number 2, and whole number 3. So I know those are my whole numbers. These are my fractions representing those whole numbers. This helps me to visualize better what I'm comparing. So what they did on the bottom was they took our number line and let's look at that denominator. What denominator do you see? Yep, it's a 4. So they have divided each whole into 4 equal parts. 1, 2, 3, and 4. And so the next section, it's also got 4 equal parts, but we continue counting on. So let's look how that comes out. I like to always add that fraction at 0 just so we don't confuse ourselves. So 0, if this part is divided into 4 equal parts, 0 would be represented by 0 fourths. 1 fourth, 2 fourth, 3 fourth, 4 fourth. So 1 whole could be written as 4 fourths. 5 fourth, 6 fourth, 7 fourth, 8 fourth. So 2 wholes could be written as 8 fourths. 9 fourths, 10 fourths, 11 fourths, 12 fourths. So if I have 12 fourths, I have 3 wholes. But they also divided our number line into halves, and that's at the top. So at the top, we see that from 0 to halfway is 1 half. From that halfway to the whole would be 2 halves. So 1 whole could also be written as 2 halves. And then next halfway point would be 3 halves. And the next one would be 4 halves. So 2 wholes could be written as 4 halves. Halfway to 5 halves, and the following part to 6 halves. So 3 wholes could be written as 6 halves. So there are many equivalent fraction names for whole numbers. If we divided it in different ways, we could find other equivalent fractions for these whole numbers. Now the bottom says, convince me. We're using our reasoning, And what equivalent fraction names can you write for 4? So now our whole number they're asking us to write about is 4. So I'm going to highlight that 4 so I remember my whole number is 4. But they're telling us they want us to use the denominators 1, 2, and 4. So I went ahead and drew out 3 number lines showing 4 parts, and that way I could use my denominator of 1, 2, and 4. So if I'm using my denominator of 1, and this is 0, and my first whole number, I'm going to go ahead and mark my whole numbers, 1, 2, 3, and 4. So if this is my whole number 1, and my denominator is going to be 1, then I know I get to, my denominator is 1, so 1 whole could be written as, and I'm going to put it beside it because I don't have a lot of room, 1 part out of 1 whole. And then if I go to my next whole, I'm thinking of 2 parts of 1 wholes divided into 1. And then if I go to my next number, I have 3 wholes that are divided into 1 equal parts. And then and my final one would be 4 wholes divided into 1 equal part. So my denominator for this first one, my equation would be 4, because that's my whole number, here's my whole number, is equal to, what's my fraction? 4 over 1. Now my next one is going to be representing my denominator of 2. This time, each section is going to be separated into 2 equal parts, into halves. So first of all, let me go ahead and get my whole number. This time I think I'm going to write my whole number above it so I have more space for my fraction. So here's 0, here's 1 whole, 2 whole, 3 whole, and 4 wholes. But I'm going to divide each section into halves because I've got to represent it with 2 as my denominator. So if I go halfway between 0 and 1, it's about right here, and that would be 1 half. And getting to my next halfway point would be 2 halves. My next halfway point would be, that's right, 3 halves. My next halfway point would be 4 halves. And then it would be 5 halves and 6 halves. Then we would go to 7 halves and 8 halves. And remember, just like up here where I was trying to find what would be the fraction for 4 wholes if 1 was my denominator, I'm going to now look to see what is my fraction for 4 wholes with 2 as my denominator. That's right. It's going to be 4 wholes is equal to 8 halves. Now the last one they told us to do was to represent our denominator with 4. And I'm going to go ahead and write, again, our whole numbers above it. 1, 2, 3, and 4. I tried to keep all my whole numbers lined up. It's not a very big workspace, so it's kind of crowded. If you needed an extra sheet of paper, always, you know that's fine. So I'm going to start with that 0 and put my fractions below. I have 0 fourths, because this time I'm dividing my number line sections, my whole sections, into 4 equal parts. So 1/4, 2/4, 3/4, and 4/4. We're going to keep on going. And I'm going to divide this one into my 4s. 5/4, 6/4, 7/4, 8/4. And I got to continue because I'm not to 4 wholes yet. 9/4, 10/4, 11/4, 12/4. I got to keep going. 13 fourths, 14 fourths, 15 fourths, and 16 fourths. Whew, that was a lot. So if I divided my wholes into fourths, I could see that 4 wholes is equal to, let's circle it so we can keep our numbers together, 4 wholes is equal to 16 fourths. Wow. Now when we look at this, do you see any relationship between this fraction that we have? If I've got 4 wholes, I can see that 4 times my parts that it's divided into, 1, is going to equal 4. Look over here. If I have 4 wholes and I'm dividing it into 2 equal parts, 4 times 2 equals 8. And if I have 4 wholes and I'm dividing it into 4 equal parts each one, how many parts would I have altogether? 4 times 4 equals 16. So we can look at a fraction and a whole number as representing the multiplication, but we also could look at it as division in the reverse. Let's continue on. Another example that they show us is if you're having trouble understanding and looking at that number line, we could use fraction pieces. Just like we used our fraction circle, we could use fraction bars. So it says you can use fractions to name whole numbers. The whole focus of our lesson. 12 1/3 fraction strips equals 4 whole fraction strips. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 pieces of fraction strips that are divided into thirds. So we would have 12 thirds. And let's see, it says all whole numbers have fraction names, so we could write that 4 as 12 thirds. Or we could turn that around because of that commutative property. 12 thirds is equal to 4 wholes. Let's take a look at that. It's kind of interesting. If we have a fraction, 12 pieces that were divided into, each whole was divided into 3 equal parts, could we say 12 divided by 3 equals 4 whole parts? We sure could, because fractions represent our division and multiplication because they're inverse operations. But if that's confusing for you, it's okay. That's just another part that I know some people will find that helpful, others might not. Always rely on what strategy works best for you. You also know that 4 equals 4 over 1. So we could have 4 wholes represented by divided into 1 part. Each part divided into 1 part would be 1, 2, 3, 4 parts divided into 1 equal parts would be 4 is equal to 4 over 1, which is also equal to 12 over 3. This fraction at the very end here, in case you're not understanding, would be 4 over 1, and the green fractions divided into thirds would be 12 over 3. That makes these fractions equivalent to 4. So we could write all of those in line just like they did. We could reverse that, change the order, because the commutative property tells us that we can change those orders when we have our equal signs here. So let's take a look. We could say 12 thirds is equal to 4 over 1, which is equal to 4 wholes. Now, let's look at explaining how you know that 4 over 1 is equal to 4. I'm going to tell it to you, and let's see if you can follow along. Well, the first thing I know is that this denominator 1 tells me that each whole is only divided into 1 equal part. The numerator 4 tells me I have 4 of those parts. 1, 2, 3, 4. So therefore, 4 over 1 is the same thing as 4 wholes. Let's look at number 2. Complete the number line. Now we've done number lines like this for quite a while. I think that it's not going to be very difficult, so let's just take a look. The top part of our number line, I can look at the denominator and it tells me that it's divided into thirds. So the one they don't have there is 0 thirds, right? So if I'm looking at it divided into thirds, from here to here is 1/3. It's kind of confusing when they have two numbers on the same number line. And then from here to here is 2/3. And then from here to here is 3/3. And that is our 1/2. Let me highlight that for you so you can see how we're matching these up. So here's my whole from 0 to 1, and it is divided into 3 equal parts on the top. Now, these other lines that are in between that might look a little confusing, they're following along with the bottom part of the number line that they are dividing into sixths. And I know that because I already see their denominator is 6. But let's continue with our thirds. I wanted you to know why I was skipping one spot each time. So now my next whole number is 2. And so from 3/3, if I divide this into 3 equal parts, I would have 4/3, 5/3, and 6/3. So the whole number 2 could be written as how many thirds? 6/3. Look at the bottom. Now on the bottom, we are doing sixths. It's dividing into 6. This time, we're looking at each of these individual marks because they took the whole and they divided it into 6 equal parts. Let's count them. 1, 2, 3, 4, 5, and 6. 6 equal parts. So I like to start with my 0/6. And then, of course, we have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. So all the way down to the end would be 12/6. So if I look at 2 wholes, what would my fraction be if I've divided my wholes into 6? It would be 12/6. Look at the number line and write 2 equivalent fractions for each whole number. So I'm looking up here and they're saying 1. I'm going to find my 1/2. Here's my 1/2. When I look at my 1/2, if I had it divided into thirds, what is that number that we came up with for our fraction? That's right, it's 3/3. But they're also asking me, what would the fraction be if it was divided into 6? So I look right below, yep, 6/6. And then for 2 wholes, this time we're looking at the 2 wholes, the whole number 2. Here's my whole number 2. At the top part, with it divided into thirds, it would be 6/3. But at the bottom part, when they divided the number line into 6, it would be 12/6. Did you notice that multiplication pattern that we see here? 1 times 3 equals 3. 1/2 times 6 equal parts equals 6. 2 wholes that are divided into each part 3 equals part. 2 times 3 equals 6. 2 wholes when it's divided into 6 equal parts. 2 times 6 equals 12. Now I'm telling you that because this next part is where my number lines are going to come in handy, or I could look at my multiplication. But let's take a look at the number lines also. That's why I took my number lines, and this top number line is divided into 1/2. And I've already written in the fractions. The second number line is divided into halves. So all you'll notice that my denominator is 2 all the way across because it's divided into halves. And I've already written the fractions. The third number line is divided into thirds. And so it appropriately goes across, so we could find out what the fraction is for each of these. The fourth number line is divided into fourths, and again, all the way across. Now look at the next one. I skipped 5 because I already looked ahead and saw that we had no denominators with 5. But our next denominator that they're going to ask us questions with is with 6. But it got really tight trying to write each of these numbers in. So once I got to that 2 wholes, which is 12/6, I went ahead and just counted in my head, which is one way. So if this is 12, 6, 13, 6, 14, 6, 15, 6, 16, 6, 17, 6, and 18, 6. I already knew. Or what I did was I took the whole number 4, multiplied it by 6, because I know each part is divided into 6 equal parts, and 4 times 6 was 24 6. 5 wholes times 6 parts is 36. 6 wholes times 6 equal parts is 36 6. I just did this to make it a little bit quicker because this lesson is a little bit long today. So I'm looking at the bottom and I have 4 wholes. It's telling me, first of all, to write 2 equivalent fractions for each whole number. You can draw number lines to help. Now, if the number line is a little bit harder for you, just wanted to let you know you could also draw shapes. So let me show you this strategy as well. So I took, and the first one says 4 wholes is equal to what if we divided it into halves? So I took my 4 wholes. Here's 1, 2, 3, 4 wholes. And I knew I was going to have halves. So I took each of those and I drew halves. So let me show you how I did this with a fresh piece of paper so that it makes sense to you. So I took 4 wholes because I knew I had 4 wholes. 1, 2, 3, 4. And it says to divide it, because I know my denominator tells me how many parts each whole is divided into, is into halves. So I'm going to divide each one into halves. So if this is the whole, and I know my denominator is 2 each time because it's divided into halves, this is 1 whole, but it has 2 parts. So one whole could be represented as 2 halves. If I had 2 wholes, it would be 1, 2, 3, 4 halves. And if I had 3 wholes, it would be 4, 5, 6 halves. And 4 wholes would be 8 halves. So I know that 4, looking at it and divided into 2 equal parts, would be equal to 8 halves. But what if it was divided only into single parts? Well, first of all, I already know I've got 4 wholes because they're telling me that. So 1, 2, 3, 4. Sorry, I should have used a different color. And now I'm going to write my fraction. This time each part's only divided into 1 equal part. So this one would be, that's right, 1 over 1. The second one, how many wholes do I have now? How many pieces? 1, 2 pieces that are divided into 1 equal part. 3 over 1 and 4 over 1. So my answer for 4 wholes that are divided into 1 equal parts would be 4 over 1. So this strategy might be a good strategy for you. The other strategy that we could have used also was 4 wholes divided into 2 equal parts. So 4 times 2 equals 8. Or 4 wholes times 1 part equals 4. And then again, here's where this fraction line is going to come in handy because we could relate it to fractions on a number line. So I'm looking at 4 wholes, and I'm going to bring this a little closer. If I'm looking at 4 wholes that are divided into halves, I find my number line that's divided into halves, and I go to my whole numbers, which I've already boxed in. 1, 2, 3, 4, 1, 2, 3, 4, and I see that my fraction for that one would be 8 halves. And if I look at my number line that the denominator is 1, because it's 1 equal part, and I've got 4 wholes, if I start with 0, I'm going to find my 4 wholes, 1, 2, 3, 4, and I see that my fraction is 4 over 1. So this number line will be very helpful. Now I'm going to go quite quickly through this. If you need to pause it and go slower, you know that is absolutely okay. So let's take a look at this one. Number 5, 1 whole divided into 4 equal parts. So I got to look at my, I could do the multiplication. 1 times 4 equals 4. Let's check it out. So divided into 4 equal parts. Here's my number line divided into 4 equal parts. I'm looking for the whole number 1. Here it is. Yep, 4 over 4. Now, what if it was divided only into 1 equal part? let's try that multiplication. 1 times 1 equals 1. Let's find the number line that's divided into, with the denominator of 1 for 1 equal parts. Go to my 1 whole, and what is my fraction? That's right, 1 over 1. So for the sake of time, I'm going to go ahead and work these with you using that multiplication pattern. So 2 wholes divided into thirds, 2 times 3 equals 6. Or 2 wholes divided into 1 equal parts, 2 times 1 equals 2. And you can look at that number line, pause it, and find it on the number line to see that that does equal out. Number 7, 5 wholes divided into 2 equal parts, 5 times 2 equals 10. Or 5 wholes divided into 1 equal part, 5 times 1 equals 5. Now at the bottom, it's a little bit different. This time they're telling us the 2 fractions that are equivalent, and they want you to tell us what is the whole number. So we're doing opposite. So this time we got 6 halves is equal to 3 over 1, which is equal to, well, I got a couple different ways I can do this. I can look at that number line, and I see that I have 6 halves. So I'm going to look at my number line that is halves, and I'm going to find 6 halves. Whoop, found my fraction 6 halves. 6 halves is equal to what whole number? That's right, 3. Now if I looked at my number line with 1 as my denominator, and I've got 3 over 1, I'm going to find my, there's my 3 over 1. So what is the whole number? 3. Let's look at this relationship also. 6 divided by 2, so 2 times what equals 6? 2 times 3 equals 6 is equal to 3 wholes. 3 divided by 1, what times 1 equals 3? Oh, that's right, it's 3. So we've got a lot of different strategies that we could be using. I could also use my shapes again by drawing my parts to represent each one of these. So let's look at number 9. 3 thirds, 6, 6. 3 divided by 3 equals, well, that means 3 times what equals 3? That's right, 1. 6 divided by 6, or 6 times what equals 6? 1. Remember, anytime your numerator and your denominator are the same, it's representing 1 whole. 8 fourths is equal to 6 thirds, which is equal to what whole number? Well, we have 8 divided by 4. 4 times what equals 8? 4 times 2. 2 wholes. Let's see if that equals the next one. 6 divided by 3. What times 3 equals 6? 2. And again, I could look back at my number lines and check each one of these to make sure. Number 11, 9 thirds. 9 divided by 3. In other words, 3 times blank equals 9. 3 times 3. Let's check to see if that's correct from my other fraction. 12 fourths. 12 divided by 4 is the same as 4 times blank equals 12. 4 times 3. And yes, it does. Now, the only other problem that we're going to do on our assignment for today is number 18. Complete the equations, match the fractions with their equivalent whole numbers. So here we go. Remember, we've done these patterns before. We're only going to choose one of these because only one of these is the correct answer. Here are the whole numbers. We've got 6 over 1, which is equal to 12 over 2, which is equal to what whole number? Let's use that strategy that we just tried. 6 divided by 1 equals, 1 times blank equals 6. 6. Let's check for this one. 12 divided by 2. That would be the same as 2 times blank equals 12. 6. So guess what our whole number is? You got it, 6. And then 6 thirds is equal to 4 halves, which is equal to which whole number? Well, 6 divided by 3, or 3 times blank equals 6. 3 times, 2. Let's check it out for this one. 4 halves. 4 divided by 2 equals 2. Yes. So 2 is our whole number for this one. 4 over 4 is equal to 1 over 1. Remember, anytime our numerator and our denominator are the same, our answer is going to be 1. And this last one, 8 halves is equal to 16 fourths. 8 divided by 2 is the same as 2 times what equals 8? 4. Now for your homework, you are going to do only the odd numbers in your homework. So we're going to do 1, 3, 5, 7, 9, 11, and then on the very back, only that last number, 19. Again, I apologize this was such a long lesson, but there's a lot of information in it. If you have any questions, feel free to have your mom or dad get with me. All right, have a great day, boys and girls.